Hello and welcome to this module. We are going to cover C language in this module, and the topics are, as shown on the screen, we are talking about data types, conditional statements, if condition and switch condition. We'll talk about some operations, greater than, less than, equal to, not equal to, and so on. We'll also talk about loops, looping constructs, which is for loop and while loop. Okay. So let's begin. So I'm going to launch ViewGen. You can also practice these coding in C language on any IDE like IDE by Bolland or Turbo C, but we are going to use the editors given by ViewGen. I'll create a new script. Let it be of any protocol type. I will select Web HTTP HTML protocol. So we'll create this script. We are not going to do any recording because we are only practicing C construct, C language data types, and how to get them on script, how to get them on output window. So we'll cancel this recording. As I mentioned, you can have Turbo C editors also. So if you just for your information, if you want to download any Turbo C editor, what you can do is you can say download Turbo C for your operating system. Mine is XP. So you can use any of these links to download Turbo C editor. This is an editor with compiler. So what it will do is it will show you an editor where you can write your code. You can compile and run your code from this compiler. Okay, it looks like a blue screen, typically for creating C and C++ programs. However, we don't need it when we want to learn C. We can always use ViewGen editor and we can learn programming on this editor as well. Although there will be some commands that might not be working on ViewGen, I'll tell you what are those. Okay. So the first thing that we'll cover in any language is how to print a message. Okay. In C, if you're practicing on C compilers like Turbo C, there's a command like printf. Okay, and in between you can put message here. But in Loadrunner ViewGen, this printf API, the API in which this printf function is defined, is not included. So this is a new function here corresponding to LR, which is LR_output_message. This is the function that lets you print message on the output window. Okay, so I can just say hello, and you can print this hello message on output window. I'll simply run this program. And see, this hello is printed on action.c line 3. Okay, so this is how we can simply print out messages. If you wanted to do so in your C compiler, then this is how you will do message hello, or any string for that matter. If I simply want to print hello, I can include just hello in double quotes under printf. Okay. So printf statement is going to give you this on the input-output console, which we cannot see from here. Okay, that's a DOS-based console, so black window. So we don't need to call these functions. Instead, the same functionality will be done. We can see the output in this replay log using LR_output message. This is a function given to us by LR. It's an LR API function. That is why it starts with LR_. Okay. Let's talk about data types and variables. Now, a variable is something in which you store a value, as it says variable, whose value can vary. For example, if I want to create any variable in C, there are n number of variables. For example, you have integer type, float type, double, short, long. Okay. So if I want to create a variable A and want to put some value into it, say 12. Okay. So I have to define, I have to tell the compiler what kind of variable it is. Why? So that it can store that much memory for this variable. So if I tell int A is equal to 12, int is the data type, A is the name of the variable, and 12 is the value in it. Let me show this to you, what happens from memory perspective when we say int A is equal to 12. So what happens, you see that there is a memory chunk available and there are blocks here. This is how memory looks like. Please bear with my drawing, pretty bad, but then I can explain better with drawing, so I'm using it. So you have memory blocks like this, and each of these memory blocks has some address, say 1, 2, 3, 4, and so on. Okay, 5, 6, 7, 8, 9, 10, 11, 12. So these addresses might not be as simple as it looks here. There might be bigger numbers, 001 or something in hexadecimal string. So say when I do this step here, int A is equal to 12, what compiler will do is it will allocate some memory to this variable A. That means it will block some memory blocks and will name those blocks as A and will store the value 12 into it. Now for example, this memory is already in use, not available. This memory is already in use, not available. Okay. So this is how memory chunk looks like. When you say int is A is equal to A, depending on the data type, int, it will block the required memory. Int will take 2 bytes. Each of these blocks is 1 byte. So what this will do is, it will block 2 such bytes, 2 blocks, and it will give a name to it named as A. And the value it will store in this block is 12. So when we say A, what it does internally is it is going to book these 2 blocks, these 2 bytes for variable A, and will store 12 in this block. So that is why data types are important. These are important before declaring any variable, to tell the compiler as to how much memory to reserve for that variable. Okay. Similarly, we have more variable types, data types. Say short is equal to 1. Short is nothing but a data type like integer. It will store integer value, but the memory allocation, the amount of memory to store this variable will be less than that required for integer. It will be half of it. So it will allocate 1 byte only to store any variable of type short. Any variable of data type short, it will allocate 1 value. So if I say s is equal to 1, what it does is it will give this name s, like we can access it, we can call it s block, and the value to store is 1. Okay, I guess this is clear that whenever we define a variable like this, the data type is basically to tell what amount of memory chunks to how many bytes to reserve, what is the name to be given to that block of reservation, and what is the value stored inside that memory. Okay, so this way we can have more variables or data types. Float, F. Float is nothing but a variable of a data type in which you can store decimal numerics. Okay. So let's see how we print then. Over here we'll use LR_output method. So if there is an IntelliSense being shown to you, giving you complete function call, you just click on it and it will populate, it will write down the method name on its own. Now suppose we want to print the value of variable A. So since A is an integer, what you can do is you can write %d here and then write the name of the variable. So this is the syntax to print the value of any variable of type integer. %d is what you need to give for integer, and similarly if you want to print short data type, again %d, because it is storing an integer, just need to change the name of the variable here. When you want to print float, what you can do is you can have %f here and name of the variable, which is f. Now let's execute this program and see whether it displays or not. So you see line number 14, when you double click in replay.log, it will highlight the line editor where corresponding to which this message is shown. So LR output message %da, it is going to show you the value of variable a, which is 12. So it has displayed 12. Then value of s in the next line and value of f float data type in the next line. So this way we have variables. We can declare variables. We can initialize them with some value, like we have initialized a with value 12, and we have more data type, like one more data type like double, which stores nothing but float value, but the size for this variable is double than that of float. Float is 4 bytes and double is 8 bytes. Okay, meaning to say you can store bigger values. There's another one, log. Log is double the size that of integer, that is 4 bytes. Integer is 2 bytes, short is 1 byte, and long is 4 bytes. Okay, so this way you can have variables declared and initialized, and using this method, using this function called LR_output_message, you can print these functions. Not only that, you can also print the value of I is %d. So wherever it will find %d, it will look for the next argument, and whatever is stored in that variable, that becomes next argument. It is going to put that value, replace the value in the place of %d. Now let's have a look when we run this. This is the value of I is 12. So whatever you give in LR_output message, it is going to give you show you that message in replay log. Okay. There is one more data type. These are all basic data types. There is one more basic data type called character, CHAR. Okay. I'm creating a new character, C, and in this character data type, you can only have single alphabet stored. Okay. So in single quotes, you can say D. Okay. So what it means is I have created a character. I have created a variable named C of type char, of character type, and the value that is stored in variable C is D. Okay. So now when I want to print this, so to print a character, you will need to give %c here and value of the character, name of the variable, that is C. But what is there in the variable is D. So it will print out D. Line number 26, D is printed out. Okay. So this is about basic data types. Now we have only seen how do we declare them, how do we initialize, and how do we print the value in output window. Okay. We can also do some operations on data types. For example, the integer I contains 12. Now I want to create a new integer. Say all the declarations will happen in the beginning. Okay. If I want to create a new integer, say counter, and I initialize it to 0. Okay. The initial value that counter contains is 0. I want to manipulate the value of counter. Say counter is equal to 20 plus I. Okay. So what I'm doing is I am doing this mathematical addition operation on 20. This is the constant, and on I. I is of integer type and has some value. So I am doing the mathematical operation addition on 20 and I, and whatever is the sum, I'm putting in counter. Okay. So the counter, which was earlier 0, after this statement is executed, is no more 0, and it has some value in it. So let's print what comes in the value. What I mean to show over here is that you can do some operations on variables. The new value of counter is, and the new value is, counter is of type integer. So I'll say %d and counter. Please note that this counter, this variable, is not put in double quotes. Many a times we do this mistake. If you want to print any variable value, we put it as double quote, under double quotes. This is not correct. So I will execute this program. It says undeclared identifier I. Okay, maybe I have not printed I. Oh, I have it as A, not I. By mistake, I put it as I. So if you use any variable which is not declared, see the kind of message you get. The error message is undeclared identifier. That means this identifier I is not declared. So compiler is not able to recognize what this I means. Okay, accidentally I put I instead of A, so I'll put it A here. Now the counter should contain the sum of this constant 20 and whatever A contains. A contains 12, so 20 plus 12 is 32. That's what it says. New value of counter is 32. Okay. Now, as it says, A is a variable. What it means is whatever it stores can vary. Now, A stores 12 currently. I can change this value to say 45. Okay, which is of integer type. So when I do that without changing the code, the counter value will also change. And since counter is also a variable, it can also contain a new value. So when you say variable, you can overwrite any value. You can store any value into that variable. Okay. Now after this, suppose I want to say counter is 6. Okay. This is what we mean by variable. You can put any value into it at any point in time. See, the new value of count is 65. After that, I set the counter back to 6, a constant value. I have initialized again. Initialization is in the beginning, so I have assigned a new value to counter. This is assignment, and here I see the new value. So this is what we mean by variable. You can change the value stored in a variable. So this is about basic data types, about variables, and how do we assign value to variables, how do we initialize variables, and how do we print, how do we see what value is stored in that variable. Okay. Now let's move forward, and we'll talk about some little bit of more details, talking about some constructs. These are called conditional statements. Conditional statements. Okay. Now suppose in our program, when we are building logic, we want to apply some logic to decide, if we have two values, we want to see which is greater. Okay. That kind of logic also can be applied using any programming language with the help of syntax. Or if you want to do some action, based on some condition. For example, let's have a look. What I'll do is I'll create a new action. Let this be for variables and data types. I will create a new action where I will take conditional statements. I'll say conditional. Okay, in this new action, I will create a conditional statement. I'll say int any number, any variable I, and I'll give some number to it, 8. Okay, so I have created a variable called I of type int and has value 8 in it. Now I want to print some value, some message. I want to say hello world only if I is greater than 5, and I don't want to print anything if I is not greater than 5. Okay, so this is based on some condition. Don't do anything. Okay, so there is one condition that we will evaluate. Now the condition is if I is greater than 5. So when we write this expression during execution, this expression will be evaluated. Now I is equal to 8. So this expression will become 8 is greater than 5, and the result of this evaluation will be either true or false. Now is 8 greater than 5? It is yes, that is true. If it is true, if this expression is true, the control will go inside this curly braces. Okay, and whatever I have written in this curly braces, that will be executed. So I will write hello world. This is what the condition was. I want to write hello world only if I is greater than 5, and if I is not greater than 5, the control will not go inside this inside if condition, and it will exit. All right, so let's run this code. So we are in conditional.c file, 12th line, hello world is printed. Why? Because 8 is greater than 5. Now suppose I change this value to 2. So what will happen? I is greater than 5. This will be evaluated and I is 2. 2 is greater than 5. It will result into false. Hence, it will not go inside this. It will not execute the statement. Let's execute and see. So what has happened is starting action conditionals, ending action conditionals. There is nothing that is executed because this evaluation returned false, and we did not ask it to do anything on false return. However, we can do that else with else. So what we mean is that if I is greater than 5, then go into the first block here. Else, if not, then do something else. Okay. So I will put a message which is descriptive and say I is greater. If I is not greater, then I is lesser than 5. Okay, so let's run this and see. The message that we get is I is less than 5, which is actually the case. So in this way, we can use this conditional constructs if else to do certain business actions depending on some condition. Okay. There's another case over here. If I simply write I here and no evaluation, so what it will do is anything which is a number over here, 1, 2, whatever, it will be taken as true. So now this condition will be taken as true. I is greater than 5, because we have not done any condition, anything to evaluate. It will evaluate I itself, and when it says I is equal to 2, so it is a number, it says it's true. So it will assume, if you do not give any expression so as greater than or less than, and only the number, it will evaluate it as true. There are more operations that you can do, like less than 2 or less than equal to 2, okay, or not equal to or equal to. So I will show you how we write equal to here. Double equal sign will evaluate the equation as equals, okay. So you don't have to write single equal operator, you have to use two operators. So I am writing that when I is equal to 2, then you print I is greater than 5. So you see, I is greater than 5. It has gone into this statement because I is equal to 2. Now, if you want to write, if you want it to evaluate when I is not equal to, this is how you will write not equal to. Okay, exclamation mark and then equal. The exclamation is not. So when I run this program, you see I is less than 5. That means I is not equal to 2. Then it went into this statement. This is about condition statement. This is a very small example. In real time, what you can do is you might want to compare two strings to see whether this string matches or not. If you are doing any business process, you want to check what is the return code. Okay, what is the return code? Every maybe in a module, if you do any functionality, it will return you some status code. So depending on the status code, you want to do certain action or you don't want to do certain action. So in that case, in real time, you might use this if-else condition. Okay. To get more hands-on, you just can do some exercises given for this module. Okay.